and good happy Friday to Algebra. We're covering PO47 today, which I promised would be fun, and I fully intend to cash in on that promise. But we're going to be multiplying monomials by polynomials. Morning, Few Jack. Morning, Few Jack. And so like we talked about a couple days ago, what are we dealing with here? Okay, we've got a monomial times a polynomial, so it'll be a one-term expression multiplied by any other type of expression. Because remember, technically polynomial can refer to monomial or a binomial or a trinomial or even more than that. And you probably recognize a lot of what this page is throwing at you because we've done it before. Back in PO7, we talked about the distributive property, right? Where you've got something going on inside parentheses and a coefficient on the outside here. How would you multiply 7 times the quantity of 2x plus 3? What's that distributive property tell us to do? Kylie?
You multiply 7 times 2x and then 7 times 3.
Yep. And why can we multiply 7 by 2x and combine them? Because if it was 7 plus 2x, we wouldn't be able to, right? So what's the difference with multiplication? Why, even though they're not like terms, we can combine them to get 14x. Kylie?
Because the way it's written, the 7 times the quantity means that there's 7 2x's.
Right. Okay. In addition to that, if we had 7 plus 2x versus 7 times 2x, what operation is happening between the 2 and the x? We're multiplying, right? And as we know, we can multiply things in any order. Okay, so it's okay to combine the 7 and the 2 to get 14, even though we don't know what x is. Versus 7 plus 2x, if we added 7 and 2 to get 9, what mathematical law would we be breaking? Order of operations, right? In this case, we have to multiply 2 and x first. We don't know what x is, so we can't multiply it, therefore we can't add 7. With multiplication, that rule changes. So that's fun. And then 7 times 3 would be 21. So 14x plus 21. Okay. Next one, similar thing. Distribute in the negative 8. Tell me what I get. Elliot? Negative 24x minus 32. Next one, distribute the 5. Tell me what I get. Aiden?
Negative 15x minus 40.
Negative 15x minus 40. And lastly, negative 10 times 4x minus 9. Tell me what I get. Max?
Negative 40x plus 90.
Negative 40x plus 90. That negative 10 times negative 9. So you've done that before, right? If you are comfortable with the distributive property, you've already got half of PO47 down. The other half we learned in PO15, where we combined exponent expressions. Who remembers the rule for multiplying by the same base as we're doing here? Which now we recognize this as multiplying 2 monomials. Right? We kind of put a term to that thing. But what was our rule for this?
You add the exponents.
Exponents are added. And coefficients are multiplied. Okay? So this would give us 12x to the 6th. And the reason why those exponents are added is if you look at it in expanded form, 4 times x times 3 times x times x times x times x, we've got 6 of them, all being multiplied together. And we can write that as x to the 6th. What do I get for my next one here? Negative 12n cubed times 2n to the 10th. Alex?
24n to the 13th.
Negative 24n to the 13th. Okay. Next one? Dyer?
Negative 14n to the 10th.
Negative 14n to the 10th. Okay. Coefficients multiplied. Exponents added. And last one? Bryn?
27x to the 11th, y to the 6th.
Good. 27x to the 11th, y to the 6th. This y, even though it's not written, does have a power of 1. And 1 plus 5 gives us 6. So you've done that before too. And if you understand both PO7 and PO15, you understand PO47. Okay? It's exactly the same thing, just kind of putting those two concepts together. All right? Questions on this, or anyone need the notes? Okay. So down to some practice examples here. 2x times 3x plus 8. We're multiplying. Who is that? Morning frame. We are multiplying the monomial 2x by the binomial 3x plus 8. So to do that, distribute 2x times 3x. Anybody? 6x squared. 2x times 8. Anybody?
16.
We're done. Yeah. Why can't we combine those? They're not like terms, right? X squared is not the same value as x. Different powers. Vince?
How did we get the power?
2x times 3x, if we think about that in expanded form. 2x times 3 times x. We can multiply things in any order, right? So the 2 times 3, we can combine to get 6. Then x times x. How do you write x times x using power? X squared. You know? If you think about it with our rule from PO15, each of those x's have a power of 1. So when you add those powers, you get 2. Okay. Next one, similar thing. 8x times 7x squared. 8x times 2x. 8x times 1. You're distributing. And then you're applying those rules for simplifying exponent expressions. PO7 and PO15. Who can confidently, with gusto. William!
Alright, 56x cubed plus 16x squared plus 8x.
I've never been more proud of you. Excellent. That is exactly right. Okay. Just remember this x has a power of 1, even though it isn't written. Right? So you got 1 plus 2 to get that 56x cubed. 1 plus 1 here to get that 16x squared. And then 8x times 1 is just going to be itself 8x. Any on here that look like they're worth our time going over? Beckman?
The last one.
Of course. Of course. The
The
last one.
last one.
Is that this one here? Is there a row beneath it?
Rosie.
Okay. I gotta arrange this one out.
Yeah.
Here we go. 9x to the 10th times 3x to the 5th minus 6x to the 12th minus 8 minus 3x to the 5th. Let's make our lives a little bit simpler.
What? Combine like two.
How can I simplify this expression before I go into my multiplying stuff? Yeah.
Get rid of both of the 3 and the 3x and the negative.
Right. If you're paying attention, you'll realize that inside the parentheses, you've got a positive 3x to the 5th and a negative 3x to the 5th. Those will cancel out. Right? So really, you're multiplying 9x to the 10th by negative 6x to the 12th. Don't forget about that sign, minus 8. If you didn't simplify first, you would realize after multiplying, you'd have a 27x to the 15th and a negative 27x to the 15th. You should cancel them all then, but might as well do it first. No reason not to. And so what we get from this, 9 times negative 6 is a negative 54. X to the 10th times x to the 12th, that's x to the 22nd. And then negative 72 x to the 10th. Okay. Your last thing to check, we haven't talked about this yet, but is this in standard form?
Yeah.
Yes, it is. So we're going to go. Elliot.
Can we do negative 8x5 or just the one part?
Sure. Oh, look, we get a PO on Monday, too.
Oh, yay. Yay. That's great.
Yeah.
What's the difference between a PO and a CO?
Oh, so in order to pass algebra and be allowed to move on to geometry, you have to show me that you understand all of the POs that we covered during the course of the year. These are like the most essential algebra concepts, whereas the COs are good to know but not required. So when we take tests and you do your retakes and things like that, all the POs you have to pass the POs. So they're very important. Probably the most important things you'll ever learn in your life.
That's so good.
PO stands for power objective, by the way.
Wow. CO stand.
Course objective. Yeah.
So if you know all the power objectives, you're really powerful.
You are set for life. Set for life.
Because we have geometries.
All right. How about this? Negative 8x to the fifth y squared, and then in the parentheses, we've got a whole bunch of terms. Okay? We are going to be distributing this. And so, Vince, what's our first term of our solution going to be?
Another question.
Yeah.
Do we have to put the powers in order? So 2, 3, 4, 5, 6, 7, 8, 9, 10.
So the standard form is actually from greatest to least order.
Right.
Yes. And this one kind of throws a little bit something funky at you. So we'll talk about this one once we're all done. Okay? But give me the first term here, Vince. What would our first term be here?
Negative 16 x to the fifth y to the fourth.
Good. Okay? What would our second term be here? Elliot.
Negative 24 x to the sixth y to the third.
Good. And our third term? Kylie?
Y plus y, or no, sorry, plus 4x to the 14th, y to the second.
Just don't forget to multiply that coefficient by the coefficient there, so it'll be 32. But you got the sign part right, and you got your variables correct. X to the 14th, y squared. Okay? So now, for standard form, we talked about how the powers have to be written in greatest to least order. What you do when you've got multiple powers in a single term is you add them together. So like 5 and 4, we would think about this term as having a power of 9. 6 and 3, we would think about this term of having a power of 9. The last one, 14 and 2, we would consider this term to have a power of 16. So the 32x to the 14th y squared would come first. And then our other two terms, which both have a power of 9, then we go to that alphabetical part of it. And since x comes before y, and we have more x's in that second term, that one would come next. Okay? So first you look at powers. If they've got more than one power, you look at the sum. If there's a tie, the tiebreaker is alphabetical, which has more. So our negative 24x to the sixth y cubed would come second, and then negative 16x to the fifth y to the fourth would be our final term. Okay? Yes, Catherine. Yes, your answer should be written in standard form. Most of them are already set up in standard form for you. It's actually this one will need to be reordered a little bit here. Otherwise, this one will need to be reordered. We reordered that one already. This one should be good, and I don't know what it looks like about it. But yeah, always be verifying in the standard form. Greatest to least power. Greatest to least power. So like this one, the reason why it's in standard form already here. Oh no, this one needs to be reordered too. Let's go to one that's already in standard form. This is in standard form already because the powers go 3, 2, and then none. The next one is in standard form also because it's 3, 1, none. The next one will need to be reordered because it goes 1, 2, none. It's not in greatest to least. If you look at our second objective of the unit, we cover standard form. There's a video on that. Sophie.
So,
Yeah, you can reorder them first if that. Yeah. That's what makes this so much fun, is all the different options you have. You can simplify first, simplify at the end, reorder it first, or at the end. Okay. Questions? Other questions, comments, concerns, complaints, comments, congratulations, or criticisms? Yes.
I'd like to congratulate Will for his great.
No. It's all about me. Oh, yeah. This is for me. Do you have congratulations for me?
Oh no.
Oh, that's
Yeah.
I got a concern.
Yes.
This wasn't fun.
It wasn't fun?
No.
You look like you're having plenty of fun back there, Jack. You and your cronies look like you're having plenty of fun. All right, homework is the rest of the page. It is due on Monday. Have a great weekend. Like and subscribe.